Hi students, welcome to the lesson 2.7, Interpreting the Remainder. Let's first take a look at our lesson 2.7 scale. Please pause the video and record your learning target. By the end of this lesson, we want you to be able to solve long division problems and decide when to write the remainder as a fraction. Please remember that your goal is to be at a level 3. Let's take a look at some mathematical practices before we get started. The mathematical practice that I want you to focus on is making sense of problems and persevering in solving them. In this particular lesson, you will use this mathematical practice to more easily interpret a remainder and decide how to best express it. So how are we going to do that? Well, when working with division problems that have remainders, there are a few things to keep in mind. Number one, we can ignore the remainder if it doesn't make sense to include it in the quotient. 2, we can interpret the remainder as a fraction when it needs to be part of the quotient. And 3, we can add 1 to the quotient, also called rounding up, if we need a larger whole as our quotient. If we need to include that remainder as part of our quotient, then we're going to be adding 1. Let's take a look at our vocabulary and review before we get into our first problem. I want to remind you that the whole number that we're dividing is called our dividend. The number of groups that we are dividing it by is our divisor. Our answer to our division problem is called a quotient. And for this particular lesson, very important, our remainder number that is left over that is not part of the whole quotient. Let's go ahead and take a look at our first I do problem. In this problem, we're going to interpret the remainder and we are going to ignore it. Let me show you how that works. So we have Natalie is making a pitcher of lemonade to sell at her lemonade stand. She is going to need a lot of lemonade to sell, so she makes 3 96-ounce pitchers of lemonade. If each one of her cups can hold 10 ounces of lemonade, we want to know how many full cups, okay, keyword, full cups of lemonade can Natalie plan to sell if all cups are sold. So our question here is we want to know how many full cups of lemonade can Natalie plan to sell if all the cups are sold. Now, I threw in a two-step problem here, but I think that we can do it. So we know, first of all, that she makes 3 96-ounce pitchers of lemonade. So we don't just have 96 ounces, we actually need to multiply 96-ounce pitchers times 3 because we have 3 of them. So we're going to have 96 times 3 in order to get our dividend, the total number that we're going to be dividing the number of cups by. So 96 times 3, 6 times 3 is 8, 9 times 3 is, or we have to regroup our 1, 9 times 3 is 27, plus 1 more is 28. So we have 288 ounces of lemonade that we're going to be working with. So now we're going to divide 288 divided by 10 ounces in each one of the cups to see how many full cups Natalie is able to sell if she sells all of her cups of lemonade. So the first thing we're going to ask ourselves is, can 10 go into 2? No, it cannot. So we're going to say 10 goes into 28. How many times? It goes into 28 2 times. So we have 10 times 2 is 20. And we're going to subtract. And we get 8. And we're going to bring down our 8. And we're going to ask ourselves, how many times does 10 go into 88? The answer is 8 times because 10 times 8 is equal to 80. We're going to subtract and we're going to get a remainder of 8. And if we want to know the number of full cups, we're going to ignore this remainder because that means it's only part of a 10-ounce cup. And we need full cups. So Natalie is going to sell 28 full cups of lemonade at her stand. Let's do another I do, and this time we're going to focus on interpreting the remainder as a fraction. So in this problem, we have Curtis and Logan, and they're going on a really long distance bike ride. And they plan to bike a total is our key word, of 139 miles over the course of 9 days. If they bike an equal distance of miles each day, our question is asking us how many miles will the boys bike each day? So we want to know how many miles bike each day. That means we're going to be dividing the number of miles, the total number, 1,349, into 9 equal days to see how many miles they're going to cover each one of the days on their long distance bike ride. So let's start off with our problem. We know that we have 1,349 total miles, and we're going to divide it equally among 9 days. So first we're going to ask ourselves, can 9 go into 1 equally? We know it cannot. So we're going to say 9 goes into 13 how many times? 9 goes into 13 one time. 9 times 1 equals 9. We're going to subtract, and we're going to bring down our 4. So 13 minus 9 is 4. Bring down our 4. Next, we're going to ask ourselves, how many times does 9 go into 44? 9 goes into 44 4 times. 9 times 4 equals 36. And we're going to subtract once again. And of course, we need to regroup. And 14 minus 6 is 8. And we need to bring down our 9. And 9 goes into 89 9 times. And we know that 9 times 9 is 81. And so 89 minus 81 is 8. So we have 149, remainder 8. Now, in the context of this problem, we want to know how many miles the boys bike each day. So in this instance, it does make sense to have a fraction of a mile that they would bike each day. So we're actually going to have 149 full miles and then 8/9 of a mile that they also are going to bike each day. So each day they're going to bike 149 and 8/9 miles per day. Okay, on the next one, we're going to do this together. We're going to interpret the remainder, but this time we're going to have to understand the context in order to know that we need to round up. So we have Mrs. Downey, and she's preparing honor roll certificates for lower school. She has 286 certificates to hand out. If certificates come in packages of 24, how many packages does she need? Okay, so we need to know how many packages does she need. And obviously, the packages need to be complete. So each of those packages must have 24 certificates. So we're going to start with 286 certificates, and we're going to divide it by the packages that come in 24 each to see how many full packages Mrs. Downey is going to need in order to hand out her honor roll certificate. So we have 24 goes into 28 one time. 24 times 1 is 24, and we're going to subtract, and we will have 4, and we're going to bring down our 6. Next, we're going to ask ourselves, how many times does 24 go into 46? And it's actually going to be only one time, because if we did it 2 times, we would come up with 48. So 24 times 1 is 24. And if we do our subtraction, we're going to get a remainder of 22. Well, we have 11 full packages, but we have a remainder of 22 out of the 24. 22 certificates out of those 24. So we're going to need to round this number up. Very important, because we can't have leftover certificates and not purchase a full package. So the full amount of packages that Mrs. Downey is going to need to purchase are 12 packages in order to get enough honor roll certificates for each of the students. Okay, now it's your turn to try. I want you to pause the video and then we'll come back and check our work. And we're back. Okay, so today for your you-do, we have Miss Yolanda, and she's ordering 130 slices of pizza for Friday lunch. Yummy. And we have 12 fifth grade students that are buying this school lunch. We want to know how many slices will each student get if the pizza slices are shared equally among the students. And I have a typo. If they are shared equally among the students, what fraction of the slices will be left over? So first, we're going to figure out how many pizza slices does each student get. So we have 130 slices divided by the 12 students, which seems like they're going to be eating a lot. They're probably going to have stomach aches. And we're going to ask ourselves, how many times does 12 go into 13? It is 1 time. 12 times 1 is 12. And we're going to bring down our 0. 12 goes into 10, 0 times. 12 times 0 is 0. And so we are going to have a remainder of 10. Remainder 10. So each student is going to get 10 slices, but then we also have a question here, what fraction of the slices will be left over? So the fraction that's going to be left over is 10 slices out of those 12 students. So they each can't have one more slice because we only have 10 left over. And probably a review skill from 4th grade is that you can actually reduce this, because 10 and 12 can both be divided by 2. So if we divide each one of these by 2, 10 divided by 2 is 5, and 12 divided by 2 is 6. So we could also say that we have 5/6 of the slices will be left over. Go ahead and review the scale for your lesson at home. I want you to record where you are now that you have watched the video, and we will see you in class tomorrow. Have a great night.